Welcome to EMR Physics. I am Raju, NCERT 12th Physics. We are solving the numerical problems given in Chapter 6, Electromagnetic Induction. In this video, we are going to see how to solve the numerical problem 6.4. The problem is a rectangular wire loop of sides 8 cm and 2 cm with a small cut is moving out of a region of uniform magnetic field of magnitude 0.3 Tesla directed normal to the loop. What is the EMF developed across the cut if the velocity of the loop is 1 cm per second in a direction normal to the A. longer side, B. shorter side of the loop? For how long does the induced voltage last in each case? This is a given problem. Let us see what are the details given in this problem. There is a rectangular wire loop. Sides of the loop is 8 cm by 2 cm. It is moving in a uniform magnetic field. The magnitude of the magnetic field is 0.3 Tesla. Velocity of the loop is 1 cm per second. What is asked? We have to find the EMF developed across the cut if the cut is along the longer side and if the cut is along the shorter side of the loop. Also, we have to find how long does the induced voltage last in these two cases. Now let us see how to solve this problem. Assume that this is a rectangular loop. The sides of the rectangular loop is 8 cm by 2 cm. 8 cm is the longer side and 2 cm is the shorter side. This loop is moving in a uniform magnetic field. Magnitude of the magnetic field is 0.3 Tesla. Velocity of the loop is 1 cm per second. Now let us assume that the cut is along the longer side. We have to find the EMF developed across the cut, that is along the longer side. Since the loop is moving in the uniform magnetic field, the EMF developed is called motional EMF. Motional EMF is given by B, L, V. Here B is the magnitude of the magnetic field. The cut is along the longer side. Therefore, L is 8 cm. This has to be converted to SI unit meter. This is equal to 8 into 10 to the power minus 2 meter. Velocity of the loop is 1 cm per second. This is equal to, again converting to SI unit, we will get 1 into 10 to the power minus 2 meter per second. B is already, we know that it is 0.3 Tesla. Therefore, the motional EMF developed across the cut is equal to B is 0.3. The cut is along the longer side. Therefore, L is 8 into 10 to the power minus 2. Velocity is 1 into 10 to the power minus 2. 3 8s are 24. Here the decimal point is after one digit. Therefore, this is equal to 2.4 into 10 to the power minus 2 into 10 to the power minus 2 is 10 to the power minus 4. So, the motional EMF is equal to 2.4 into 10 to the power minus 4. Unit of EMF is volt. So, this is the answer for the first question. Second, what we have to find? We have to find how long this induced voltage lasts. The loop is moving along its shorter side out of the magnetic field. So once if it has covered this distance, the EMF will last. Therefore, we can write velocity V is equal to the distance travelled is shorter side by time. EMF is developed across the longer side, and this EMF will last once if it has travelled the shorter side. This is equal to, what is the shorter side? Shorter side is 2 into 10 to the power minus 2 meter divided by time. We have to find velocity is 1 into 10 to the power minus 2. We have to find the time. So T is equal to 2 into 10 to the power minus 2 divided by 1 into 10 to the power minus 2. We can cancel these two. 2 by 1 is 2. So this is equal to 2. Unit of time is second. So T is equal to 2 seconds. That is, the induced voltage will last in 2 seconds if there is a cut along the longer side. So this is the answer for the first subdivision A. If there is a cut along the longer side, the motional EMF or EMF developed is equal to 2.4 into 10 to the power minus 4 volt, and this induced voltage will last in 2 seconds. Now let us see how to find the answer for the second subdivision. In this case, there is a cut along the shorter side. The cut is not made very clearly. Assume that there is a cut along the shorter side. What we have to find? We have to find what is the EMF across the cut. The cut is along the shorter side. Loop is moving out of the magnetic field along the longer side. Since the loop is moving, the motional EMF developed is given by BLV. This is the motional EMF. B is the magnitude of the magnetic field. It is given, which is 0.3 Tesla. Since there is a cut along the shorter side, L is equal to 2 cm. This has to be converted to SI unit. So this is equal to 2 into 10 to the power minus 2 meter. V is the velocity. It is 1 into 10 to the power minus 2 meter per second. Therefore, the motional EMF is equal to 0.3 into 2 into 10 to the power minus 2 into 1 into 10 to the power minus 2. BLV. This is equal to 3 2s are 6. We have to keep the decimal point after one digit. Therefore, this is 0.6 into 10 to the power minus 2 into 10 to the power minus 2 is 10 to the power minus 4. Unit of motional EMF is volt. So this is the answer for the second subdivision. That is, if there is a cut along the shorter side, the EMF developed across the cut is equal to 0.6 into 10 to the power minus 4 volt. Next, what we have to find? We have to find how long this induced voltage will last. This loop is moving along its longer side. So once if the loop has moved the longer side out of the magnetic field, the induced voltage will last. Therefore, velocity is equal to, it is moving along its longer side. So velocity is equal to the distance traveled is longer side by time. What is the longer side? The longer side is 8 cm. It is converted to SI unit, 8 into 10 to the power minus 2 meter. Velocity is 1 into 10 to the power minus 2 divided by time is t. This is what we have to find. How long the induced voltage will last. T is equal to 8 into 10 to the power minus 2 divided by 1 into 10 to the power minus 2. We can cancel these two. 8 by 1 is 8. So this is equal to 8. Unit of time is second. Therefore, T is equal to 8 seconds. The induced voltage will last in 8 seconds. This is the answer for the given problem. If you find this video is useful, please subscribe the channel, share it to your friends. Thank you for watching this video.